Hello, so my name is Pierre, and I'm going to present the next case. It's about predictive maintenance and what maintenance actually is, how a good maintenance strategy looks, and how, of course, because we are an AI company, how AI can help with doing the right maintenance. So for the planning of today, we have 4 points. So the first point is what is maintenance? How does a good maintenance strategy can improve your sustainability? Then how can data help with improving your maintenance strategy? And then also how can AI help with it? And then finally, to make it a bit more concrete, I will present like a use case on how the optimal maintenance strategy should be implemented. So first of all, what is maintenance? So maintenance refers to a set of activities who keep a system in a good working condition, and in that way you can minimize the downtime, so your production process or other things stay like more fluently. You have less performance losses, so the quality of your resources are way higher, so they stay at their optimal performance level, and then you also have less breakdowns, which is of course also a huge benefits of doing good maintenance. So I've also written down 4 activities, but the number of activities can be much more broader than this. So the first one is inspection. So you just go checking up on your devices and see for flaws that you can see by eye. And then if you have identified a flaw, then you can either do 2 things. You can either repair it, if that's possible, but if it's not possible, you should replace some parts of your devices. But also like an upgrade is also a part of your maintenance strategy because it improves the optimal working conditions of your devices. So this is maintenance. How can maintenance help with improving your sustainability? So the first thing is it increases the lifetime of your devices. So if every time you try to increase the quality of your devices before it breaks down, then in the end, the lifetime of your devices will become way longer, and in that way you have to throw less devices away. So then the waste pile that you produce is lower. Another thing is your devices stay at their operational most efficiency level. So they will need less energy and you will produce less emissions like CO2 and things like that. But also another important thing is that if you keep the quality of your devices up, then they will become more reliable to use, so more safer to use. And then the people who are using them will suffer less incidents, which is of course like a huge benefit for your sustainability. Okay, so then you have a couple of maintenance strategies that you can follow. So the first one is actually reactive maintenance. And then reactive maintenance is actually not a strategy because you just keep your devices using until they break down, and then once they break down, you react and you try to fix it or you try to replace the broken parts. So this is not the best idea, but it is still a strategy. Then you can also do preventive maintenance. So preventive maintenance is just doing some routine checks. So every now and then you go to your devices and you try to see does everything still works, and if it's not still working, then you do some minor fixes. And in that way you can keep your device using for a longer time, which is of course great. But then we have the last one, and this is like, I think for most companies the most ideal one, is predictive maintenance. So in predictive maintenance you try to predict when some parts will break down. And then if you do it for all your devices that you have, then you know in advance, for that device I have to do maintenance in 2 months, and for another device I have to do it in like a couple of more months. Then I can create like the optimal scheme to do my maintenance, and in that way you can lower the peak of effort to do the maintenance. So this is the most ideal way of doing your maintenance. Okay, so now, because we are an AI company, we will also talk about data and AI. So how can data help with it? So the first thing is that if you just take all the data which is related to your devices, it can be either the physical data, like how much is the temperature inside your devices, or it can also be the output of your entire production process, like for example for a milk producing company, how much milk is produced. So it can be either type of data that is related to your devices. And if you aggregate all this data and you put it in some nice visualizations and then in a dashboard, then you can present those dashboards to some experts, and then based on the information that he sees, of course, he will know where he should look to do the maintenance, because he has such a high level of expertise. The data for him is like an accelerator to do the things that he wants to do, and he can optimize the scheme to do the best maintenance. Okay, then how can AI help with it? So first of all, you can do anomaly detection. So things don't break down without showing any symptoms in advance. So you can see some small symptoms, and this can be detected with anomaly detection. So anomaly detection is like a sub-branch in the AI where you try to detect weird behavior on the data that you have today. So say, for example, if you try to measure the temperature inside your devices and you see a peak, then this might point to something going to break down. So then you can send an alert to some expert or to the maintenance crew, and he can go and try to see what's wrong with the devices. So this is the first thing, how AI can help with it. And then AI can also help, of course, with doing the predictions. So if you have the historical data, and you have also data about when some parts break down, you can try to establish the relationship between the data and the devices and the date of things breaking down, and you can try to capture that relationship. So this is where AI is really good in, because AI can capture patterns that are not even detectable by persons. So you can train an AI to learn the patterns between the historical device data and the historical breakage data, and then you can use that AI to do predictions for the data that you have today. And then you can use it to detect future breakage. Okay, so let me just give an example on how this could look like. So say, for example, if you have a car and you measure every month the fuel consumption inside that your car does. And then you see it growing, and then in the year 2019 you see your engine breaking down. Then the fuel consumption over the past couple of years could have a relationship with your engine breaking down. So if you use that relationship, then you could use it for your next car, for example. And you can detect better when your engine will break down, and then you can do the maintenance in advance. Okay, so now how does AI look as a co-pilot? So first of all, you also have the data. So this is the thing that I presented a couple of slides ago. But then if you combine the dashboard that you have built with the data with the predictions that AI makes, and then you also put it inside the dashboard, then you can present it to the experts, and then he has way more knowledge, and then he can do the optimal maintenance using both the insights provided by the data as the AI. Okay, so let's make this a little bit more concrete. So use case. So for this, I will present the use case of a small company in Ghent. They are actually called Tokua, and Tokua tries to implement a predictive maintenance strategy for ships, because of a lot of ships still do not have the right maintenance strategy. So the problem they are actually trying to fix is that, say for example, a ship wants to leave on a trip, and in the middle something breaks down. Then a ship can do a couple of things. So he can proceed to auxiliary power sources. He can repair the broken parts on the ship. He can replace the broken parts on the ship, or he can be towed to a repair station where the actual repairs should happen. So this is something that a ship can do in a reactive maintenance strategy. So who uses it? Hopefully no one, but actually a lot of ships still. And what does it look like? Yeah, it's not really a strategy, so you just wait until things break down, and then you fix them post-mortem. Okay, so why is this not optimal? So first of all, the auxiliary power sources are not the most efficient. So most of the shipping companies will not invest in both a good primary power source as an auxiliary power source. So they are not the most efficient. They will use more fuel, they will produce more emissions, so it's not ideal. Also, replacement leads to waste, which is not good for your waste pile. then why is it not good to repair the broken part on the ships? Because the process is way harder to do on the ship than off the ship, because you do not have the right equipment, you do not have the right subparts for which you should replace things. So the repairs are mostly done suboptimal, so it could be better. And then if you need to be towed to repair station, some ship should come to you, which is of course some fuel consumption, and then you need to be towed, and then you need to restart your trip, so that's a lot of waste of fuel. So that's not ideal. So then how can AI step in? So first of all, for AI to be used, you need data. So which data do they use? So they use both physical data, so data that is acquired by sensors in the devices, and those sensors measure like the temperature, the vibrations, the oil quality, but also performance data, like how fast does a ship still is able to go, how much fuel does it consumes, how much is the power output of your engines, and that data can then be used to make the predictions of which parts will break down when, and then you can do more predictive and preventive maintenance. So yeah, the goal is then of course to execute repairs before the departure. So say for example, if you know that some parts will break down in 1 week, then it's good to maybe replace them all today if you're leaving on a longer trip. It makes sense. And then also when you have left on a trip, it's also to do the maintenance, to do the predictive maintenance still, because you can react better on the ship during the trip before things break down. So you can do already minor changes to the devices so that they don't actually break down. So some of the advantages is you have less downtime, which is huge, which is good for your revenues. You have lower unnecessary trips to the repair stations. You have a lower, you have more qualitative repairs. It's also safer for the crew, and you have less waste. So who uses this AI then? It will be the captains and the crew. And how does it look? It can be either type of alerting tool and dashboard. So this is the use case that they are trying to solve. This is also the end of my presentation.